Space Mystery Alert. In the vast, silent theater of the cosmos, a new actor has taken the stage, arriving from the darkness between the stars. It's an object designated 3I Atlas, and it has presented astronomers with a profound and tantalizing puzzle. Is this visitor a piece of extraterrestrial technology, a silent probe sent from another civilization? Or is it a far more familiar yet no less fascinating phenomenon? A fragment of natural ice, a comet born in a distant solar system and cast out into the interstellar void? The answer lies hidden in the faint light it reflects, and the story it tells is one that challenges our understanding of the universe. The story of 3I Atlas begins not with a bang, but with a faint flicker of light captured by the Asteroid Terrestrial Impact Last Alert System, or ATLAS. This network of robotic telescopes, stationed in Hawaii, Chile, and South Africa, tirelessly scans the entire night sky every 24 hours. Its primary mission is to detect near-Earth asteroids that could pose a threat to our planet. But in its vigilant watch, it sometimes finds things that are much, much farther away. On a routine night of observation, the system flagged a faint, slow-moving object. Initially, it was catalogued like any other potential asteroid. But as more data points were collected over the following days and weeks, a startling picture began to emerge. When astronomers plotted its trajectory, they found it wasn't in a closed, elliptical orbit around our sun, like planets, asteroids, and most comets. Instead, its path was a hyperbola, an open-ended curve. This is the telltale signature of an object that is not gravitationally bound to our solar system. It was a traveler, merely passing through. This confirmed its status as an interstellar object, only the third ever to be identified. Hence the 3I in its designation. The Atlas honors the survey that discovered it. This visitor was on a one-way trip, a fleeting encounter measured in months before it would depart back into the interstellar darkness, likely never to return. So, what do we know about 3I Atlas itself? Its physical characteristics are a study in uncertainty, pieced together from the faintest of clues. Based on its brightness or magnitude, astronomers can estimate its size. However, this calculation depends heavily on its albedo, how reflective its surface is. If it's dark like charcoal, it must be relatively large to reflect the amount of light we see. If it's bright like fresh ice, it could be much smaller. Current estimates place its size somewhere between 100 and 400 meters in its longest dimension. Observations of its light curve, the way its brightness fluctuates over time, suggest it has an elongated, irregular shape, tumbling through space as it travels. Its color appears to be reddish, similar to many objects found in the outer reaches of our own solar system, but slightly different from the previous interstellar visitors, Oumuamua and Borisov. To decode its true nature, scientists turn to the powerful tools of photometry and spectroscopy. Photometry is the precise measurement of light. By tracking changes in brightness, astronomers infer the object's rotation, shape, and even the texture of its surface. Spectroscopy, on the other hand, is like dusting for cosmic fingerprints. When sunlight reflects off 3I Atlas, the material on its surface absorbs certain wavelengths of light. By splitting the reflected light into its constituent colors, a spectrum, astronomers can see which wavelengths are missing. These absorption lines correspond to specific chemical elements and compounds. This is how we can determine what an object is made of, even from hundreds of millions of kilometers away. Is it rocky, icy, a mix of both? The spectrum holds the key, and it's here, in the precise tracking of its motion and the analysis of its light, that the oddities begin. 3I Atlas is an interstellar visitor with odd behavior. The most significant anomaly is its motion. The object is exhibiting a slight but persistent deviation from a path dictated purely by the sun's gravity. This is known as non-gravitational acceleration. It's as if a tiny invisible force is gently pushing it. This is the core of the mystery. For a typical comet, the explanation would be simple: outgassing. As a comet nears the sun, its ices sublimate. turning directly from solid to gas, and erupt from its surface in jets. This process creates a visible coma and tail, and acts like a set of tiny, natural rocket thrusters, altering the comet's path. But with 3I Atlas, there's a weird tale, or rather, a lack thereof. Despite the measured non-gravitational acceleration, deep observations have failed to detect the expected coma of gas and dust. If it's a comet, it's a remarkably stealthy one, outgassing a substance that is difficult to see, like pure hydrogen or nitrogen ice. This unexpected motion, combined with the lack of a visible coma, opens the door to more exotic hypotheses. One is radiation pressure. The stream of photons from the sun exerts a tiny but constant force. For a normal dense object, this push is negligible compared to gravity, but if 3I Atlas were extremely thin and lightweight, a so-called light sail with a large surface area and very low mass, solar radiation pressure could be enough to explain its trajectory. This is the basis for the most sensational theory, that it could be an artificial probe, deliberately engineered to travel between the stars. Faced with this puzzle, the global astronomical community has mobilized. Observational campaigns are underway, using some of our most powerful instruments. Ground-based giants like the Very Large Telescope in Chile and the Keck Observatory in Hawaii are using their massive mirrors to capture detailed spectra. In space, the Hubble and James Webb Space Telescopes are being tasked with observing 3I Atlas at infrared wavelengths, which are ideal for detecting the faint heat signature of outgassing or discerning the chemical makeup of its surface. Every photon is precious. Telescopes are collecting spectra to search for the chemical fingerprints of water, carbon monoxide, or other volatile ices. Telescopes are collecting orbit data with painstaking precision, refining the measurements of its non-gravitational acceleration to see if it changes as the object's distance from the sun changes. This can help distinguish between outgassing, which typically increases closer to the sun, and radiation pressure, which follows a more predictable curve. And telescopes are collecting sunlight reflections, building up a high-resolution light curve over hours and days. This data will allow scientists to build a more accurate 3D model of the object's shape and tumbling motion, which is crucial to calculating the effects of radiation pressure. The goal of all this intense observation is clear: to test natural explanations rigorously. This brings us to the central debate. On one side, we have the natural hypotheses. Perhaps 3I Atlas is a dark comet, outgassing materials that are transparent and hard to detect. Or maybe it's a fragment of a nitrogen iceberg, chipped off a Pluto-like planet in another star system, a theory also proposed for Oumuamua. Such an object would sublimate, causing acceleration, but its nitrogen gas would be nearly invisible to most telescopes. On the other side is the artificial technology claim. The light sail hypothesis is compelling because it elegantly explains the acceleration without a coma. However, it requires us to accept the existence of an alien civilization capable of building and launching such a craft. In this context, scientists urge caution. The history of astronomy is filled with mysteries that initially seemed strange, but were ultimately explained by new but entirely natural physics. Pulsars were first nicknamed LGM-1 for little green men, before they were understood to be rapidly rotating neutron stars. The scientific principle of Occam's razor suggests that the simplest explanation is often the correct one. Most oddities come from physics, not probes. The burden of proof for an extraordinary claim like alien technology is, and should be, extraordinarily high. As the data continues to pour in, scientists will systematically test each idea. If spectroscopy reveals the signature of water or carbon monoxide, the dark comet theory gains strength. If the non-gravitational acceleration perfectly matches the curve predicted for sublimating nitrogen, the iceberg fragment theory becomes the frontrunner. And if all known natural explanations are definitively ruled out, and the object's characteristics remain consistent with a manufactured artifact, then the conversation will change. But we are not there yet. So what is the bottom line? 3I Atlas is a genuinely fascinating and, for now, unexplained object. It is a precious gift from the galaxy, offering a rare chance to study matter from another star system up close. Its strange behavior is pushing the boundaries of our theories about comets and planetary formation. It represents the scientific process in its purest form, a deep mystery met with intense curiosity and rigorous investigation. The path forward is clear: science first, speculation later. Every new observation, every refined calculation, brings us one step closer to peeling back the layers of this cosmic enigma. The universe does not give up its secrets easily. But in asking these questions, in pointing our most advanced instruments at this faint speck of light, we are engaging in one of humanity's oldest and noblest pursuits: the quest to understand our place in the cosmos. The final verdict on 3I Atlas is not yet written, but the investigation itself is a journey of discovery. Stay curious.